Please pardon my scratch work, my laptop just died. So Cantor did his first 10 papers on number theory. Then he decided that calculus was his passion, and at that time calculus was called analysis. He solved open problems on the representation by trig series. He worked on the meaning of infinity. Cantor thought it was possible to add infinity to infinity, and he found later that you could add infinity and subtract infinity. In 1870, he considered an infinite series of natural numbers, which he called 1, 2, 3, 4, and so forth. The even numbers were 2, 4, 6, 8, and so on. Squares were 1, 4, 9, 16, and 25, and so forth. And he thought about pairing these numbers together. So one of the examples of pairing the numbers together were this one here at the top. He paired the natural numbers with counting numbers by 10. So 1 matched with 10, 2 matched with 20, 3 matched with 30, and so forth. So he showed that the groups had the same number of elements. Another pairing was the natural numbers to rational numbers. So 1 was to 0, 2 was to 1, 3 was to 1/2, 4 was to -1, 5 was to 2, and 6 was to -1/2. So here he proved that rational numbers are countable, and the infinity of rational numbers is the same size as the infinity of natural numbers. The infinite series of decimals with rational numbers method broke down. He showed that there's an infinite set of different sizes. Some are countable, some are uncountable. And he defined well-ordered sets and power sets. Another example was in our reading. I just took it a little bit further. So 0 went to 1, 1 went to 1/2, 1/2 went to 1/3, 1/3 went to 1/4, then 1/4 went to -1/3, and -1/3 went to 2. And this just showed you how that rational numbers were countable, because there were numbers in between the other numbers.